And we can keep this going. Let's see where we are right now. Okay, I guess I'm going to go back to here. Nope. Yeah. All right, so where are we? So that's finding two values in a list. And right, so we figured out a way to change our data. We can put in however big we want the list to go. We're generating random data, so it doesn't actually, we're not stuck trying to give it different values all the time. And we can actually put in code to time the solution, and we can actually look at that if we wanted and even plot it. And here is the values I should have started from. Okay. What happens if instead of looking for the values in the list, looking for the smallest values in the list, we want to look at specific values or determine that the value isn't in the list at all, right? This is the same thing as if X in a list, right, where we're trying to test every value. Well, the basic algorithm is straightforward, requires order of n steps, right? We could use in an index, or we could write our own loop. There's a lot of ways to solve this. It's pretty simple to do. Did we have to do this? Hopefully I didn't just give you guys the you know what? I wasn't supposed to do that. Those of you who came to the synchronous lecture, you got a little bonus. You're going to be asked to do this in the lecture exercises. That's why I didn't have this specified very well. The concept here, though, is that we can look at that, but if you have to go through every element in the list, the worst case if you're trying to find an element in the list or determine that it's not there, you have to walk through every element, and this is going to be an order of n algorithm. But what we want to kind of look at is what happens if we already have a list that is already ordered. So we've already sorted this list. Now remember, sorting is an order of n log n algorithm, and finding is only an order of n algorithm. But if we're already sorted, or maybe we have to make a whole bunch of these operations, right? So what we want to look at is, what happens? Is there a simpler algorithm? Can we do searching in less time if we already have a sorted list? And if that's the case, then maybe we can come up with something, come up with a better algorithm just by sorting and then making a lot of queries into the binary search. And we'll talk about this again a little bit more. I'll talk about this at the end of next class, because I think this is about where I got to. But I'm going to tell you that a binary search is a log n algorithm, and we talked about sorting being an n log n algorithm. So let's talk about what that means. Okay? If we have to look through everything, we have to step through a list one at a time. But if the list is already ordered, right, we know where the two n's are, we know where the 0 is, and where the length of the list is, -1, right? So we know what the bounding indices are. Well, if we pick a value in the middle, and we look at the value in the middle, and we compare the value we're looking for, and we know things are sorted. If the value in the middle here is bigger than, if the value in the middle is bigger than the value we're looking for, then we know that the value we're looking for has to be in the lower part of the list, and we can throw away the upper part. And similarly, if the value in the middle is smaller than the value we're looking for, well, then we can throw out the lower part. So essentially, at every stage, and then we move the bounds, right? We move the lower and upper, the places we're looking, we move the bounds to encompass the values that are left. And so at every stage, what we do is by doing one comparison, we can throw out half the values. So we don't have to do this one at a time, right? You've probably played this game with your parents or with your parents, where they ask you to guess a number and you have to hone in on it. And you've kind of probably figured out that if you go about in the middle, you're going to find it a lot faster than if you walk along one value at a time, right? So that's the whole concept of this binary search. And again, we will walk through this a little bit more in the next class. just to kind of wrap this up and as an intro to sorting. But the idea here is we keep the two ends, right? The length of the list and the beginning of the list. And we ensure that every value to the left of the low value is less than the value we're looking for, or less low minus 1. So 0 to low minus 1 are less than the value we're looking for. And we're going to start out at 0, so we know that either the index L sub 0 is the right answer, or it's between, it's at the other end. And high, all the values at high, we'll start that out at the length of the list. So every value greater than or equal to high is greater than or equal to x. Right? And then at each iteration, we just pick a midpoint. Right? We calculate that using integer mathematics. Right? There's the // We calculate that using integer math. And then we look to see, are we in the left half of what we have left, or are we in the right half? And depending on where we are, we move either our low or our high value. And then at the end, what we're going to guarantee is that at the end, low and high meet at the correct value, and we just return that value. So we can go through a little analysis next week, and we'll show that that's an order of log n type of algorithm, and we'll kind of use that as, or next week, next class, we'll use that to jump into sorting. All right, I think that's what I have for you. Not bad for my second time through. I cut 15 minutes off. I don't know if that's good or bad. Hopefully I didn't miss anything important. But I will see you guys on Thursday, and enjoy yourselves. Bye.